Fire alarm systems require a dedicated, isolated grounding system to ensure reliable operation and safety. The ground conductor must be sized according to the National Electrical Code, or NEC, and routed in conduit. The NEC requires a ground wire of at least number 10 American wire gauge, or AUG, copper for fire alarm systems. The ground wire must be connected to the street side of the water main or other approved grounding electrode. The neutral bar of the fire alarm fuse cutout must be bonded to the ground at the fuse cutout. Normally, bonding the neutral and ground at the fuse cutout protects the system from ground faults. However, concerns arise when the fire alarm ground wire is also connected to the main disconnect ground bar, which is bonded to the neutral. This creates a ground loop, which can cause interference and potential safety hazards. To eliminate the ground loop, the fire alarm system should have a dedicated grounding electrode that is not connected to any other grounding system. This electrode can be a separate grounding rod or can be integrated into the water main grounding system using an isolation transformer. The fire alarm fuse cutout should be fed from the line side of the main disconnect. The fire alarm system should have a surge protection device to protect against electrical transients. The grounding system should be tested and inspected regularly to ensure proper operation. It is possible to connect the fire alarm ground wire to the main disconnect ground bar. It is not recommended due to potential ground loop issues. The preferred method is to establish a dedicated grounding electrode for the fire alarm system to ensure reliable and safe operation. When dealing with electrical systems, it's crucial to understand the importance of proper grounding. Grounding, in essence, provides a safe path for electrical current to flow in the event of a fault, protecting both equipment and personnel. Fire alarm systems, being critical life safety devices, demand particular attention to grounding to ensure their reliable operation. The NEC sets the standard for electrical installations in the United States. It outlines specific requirements for grounding fire alarm systems, focusing on safety and performance. One key requirement is the use of a dedicated grounding system. This means that the fire alarm system should ideally have its own grounding electrode, separate from other building systems. This minimizes the risk of interference and ensures a reliable ground path. The NEC mandates a minimum size for the grounding conductor, typically number 10 AWG copper. This conductor must be run in conduit for physical protection. The conduit itself should also be properly grounded. The grounding conductor should be connected to a suitable grounding electrode. Acceptable grounding electrodes include the street side of a metallic water pipe, a ground ring encircling the building, or ground rods driven into the earth. The choice of electrode depends on site conditions and local regulations. Bonding refers to the intentional connection of metallic parts to create a low impedance path for fault current. In fire alarm systems, the neutral bar of the fuse cutout must be bonded to the ground at the cutout. This bonding helps to ensure that any fault current will quickly trip the overcurrent protective device, such as a fuse or circuit breaker. A ground loop occurs when multiple ground paths exist, creating a circulating current. This current can cause interference and potentially create hazardous voltages. In fire alarm systems, ground loops can be a concern when the fire alarm ground wire is connected to both the dedicated grounding electrode and the main electrical service ground bar. To prevent ground loops, it's generally recommended to avoid connecting the fire alarm ground wire to the main electrical service ground bar. Instead, rely on the dedicated grounding electrode for the fire alarm system. In some cases, an isolation transformer can be used to isolate the fire alarm system's grounding from the main electrical service grounding. This helps to break any potential ground loops. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning, power grid switching, or other events. Fire alarm systems are particularly vulnerable to voltage surges, which can damage sensitive electronic components. SPD should be installed at the fire alarm control panel and other critical locations to protect against surges. Regular testing and inspection are essential to ensure the proper operation of the grounding system. This includes visual inspections of the grounding conductors, connections, and electrodes. Ground resistance testing should also be performed to verify the effectiveness of the grounding system. The results of the testing and inspection should be documented, and any deficiencies should be promptly corrected. While it might seem acceptable to connect the fire alarm ground wire to the main disconnected ground bar, it's generally not recommended due to the potential for ground loop issues. The preferred approach is to establish a dedicated grounding electrode for the fire alarm system, ensuring reliable and safe operation. Consider a scenario where a fire alarm system is installed in a commercial building. The system includes a fire alarm control panel, smoke detectors, pull stations, and audible alarms. The NEC requires that the fire alarm system have a dedicated grounding system, separate from the building's main electrical service grounding. A licensed electrician installs a ground rod near the fire alarm control panel and connects the fire alarm system's grounding conductor to the ground rod. The electrician also bonds the neutral bar of the fire alarm fuse cutout to the ground at the cutout. During a thunderstorm, a lightning strike hits the building. The surge protection devices installed at the fire alarm control panel divert the surge current to ground, protecting the fire alarm system from damage. The fire alarm system continues to operate normally, providing early warning of a fire and helping to ensure the safety of the building occupants. In this scenario, the dedicated grounding system and surge protection devices played a crucial role in protecting the fire alarm system from damage and ensuring its continued operation. Proper grounding is not just about meeting code requirements, it's about ensuring the reliable and safe operation of critical life safety systems. Now, let's delve into the specifics of selecting and installing grounding electrodes for fire alarm systems. The choice of grounding electrode depends on several factors, including soil conditions, local regulations, and the availability of suitable electrodes. The most common types of grounding electrodes include metallic water pipes, ground rods, and ground rings. A metallic water pipe that is in direct contact with the earth for at least 10 feet is generally considered an acceptable grounding electrode. However, it's important to connect to the street side of the water meter to ensure a reliable connection to the earth. Ground rods are typically made of copper or copper-clad steel and are driven into the earth to a depth of at least 8 feet. The number and spacing of ground rods depend on the desired ground resistance. A ground ring consists of a bare copper conductor that encircles the building and is buried at a depth of at least 2.5 feet. The ground ring provides a low impedance ground path for the entire building. The NEC specifies requirements for the size and material of grounding conductors. Grounding conductors must be sized based on the size of the overcurrent protective device protecting the circuit. Copper conductors are generally preferred for grounding due to their excellent conductivity and corrosion resistance. Grounding conductors must be protected from physical damage by routing them in conduit or other suitable enclosures. All connections in the grounding system must be made using approved connectors and methods. Connections must be tight and corrosion resistant to ensure a reliable electrical connection. The resistance of the grounding system is a critical parameter that indicates the effectiveness of the ground path. The NEC recommends a maximum ground resistance of 25 ohms for most applications. Ground resistance testing should be performed using a ground resistance meter. The meter injects the test current into the ground and measures the voltage drop to determine the resistance. The ground resistance should be measured at different locations around the building to ensure that the grounding system is effective throughout. If the ground resistance is too high, additional ground rods or other measures may be necessary to improve the grounding system. The importance of proper labeling and documentation should not be overlooked. All grounding conductors, electrodes, and connections should be clearly labeled to identify their purpose and location. Detailed documentation of the grounding system should be maintained, including drawings, test results, and inspection reports. This documentation is essential for troubleshooting and maintenance. Proper grounding is a fundamental aspect of electrical safety and is crucial for the reliable operation of fire alarm systems. By following the NEC requirements and best practices outlined above, you can help to ensure that your fire alarm system is properly grounded and protected from electrical faults and surges. Let's examine the consequences of improper grounding in fire alarm systems. One major consequence is the increased risk of electrical shock. If a fault occurs in an improperly grounded system, the fault current may not have a clear path to ground, potentially energizing exposed metal parts. This can create a dangerous shock hazard for anyone who comes into contact with the energized parts. Improper grounding can also lead to equipment damage. Fault currents can cause overheating and damage to electrical components, potentially leading to premature failure. In fire alarm systems, this can compromise the system's ability to detect and respond to fires. Another consequence is the increased risk of fire. Fault currents can generate heat, which can ignite flammable materials in the vicinity of the fault. In fire alarm systems, this can create a fire hazard that could spread rapidly. Improper grounding can also cause false alarms. Ground loops and other grounding problems can introduce noise and interference into the fire alarm system, leading to false alarms. False alarms can disrupt operations and create unnecessary panic. Furthermore, improper grounding can violate electrical codes. The NEC and other electrical codes specify minimum requirements for grounding electrical systems. Failure to comply with these requirements can result in fines, penalties, and legal liability. The economic impact of improper grounding can be significant. Equipment damage, downtime, and legal costs can all contribute to financial losses. In addition, the cost of correcting grounding problems can be substantial. Therefore, it is essential to ensure that fire alarm systems are properly grounded from the outset to avoid these costly consequences. Now let's explore some common grounding mistakes to avoid. One common mistake is using undersized grounding conductors. Grounding conductors must be sized based on the size of the overcurrent protective device protecting the circuit. Using undersized conductors can limit the amount of fault current that can flow, potentially delaying the tripping of the overcurrent device and increasing the risk of damage. Another mistake is making improper connections. All connections in the grounding system must be made using approved connectors and methods. Loose or corroded connections can increase the resistance of the ground path, reducing its effectiveness. Another common mistake is failing to protect grounding conductors from physical damage. Grounding conductors should be routed in conduit or other suitable enclosures to protect them from physical damage. Damaged grounding conductors can become ineffective, compromising the safety of the system. Another mistake is neglecting to test and inspect the grounding system regularly. Regular testing and inspection are essential to ensure that the grounding system is functioning properly. Neglecting to test and inspect the system can allow problems to go undetected, potentially leading to serious consequences. Another mistake is failing to document the grounding system properly. Detailed documentation of the grounding system should be maintained, including drawings, test results, and inspection reports. Failure to document the system can make it difficult to troubleshoot problems and maintain the system over time. By avoiding these common grounding mistakes, you can help to ensure that your fire alarm system is properly grounded and protected from electrical hazards. In addition to the topics covered above, there are several other considerations related to grounding fire alarm systems. One consideration is the impact of electromagnetic interference, or ME, on fire alarm systems. EMI can disrupt the operation of electronic equipment, including fire alarm systems. Proper grounding can help to reduce EMI by providing a low impedance path for unwanted signals to ground. Another consideration is the use of isolated ground systems. Isolated ground systems are used in sensitive electronic equipment to minimize noise and interference. In fire alarm systems, isolated ground systems may be used for the fire alarm control panel or other critical components. Another consideration is the impact of lightning on fire alarm systems. Lightning strikes can cause voltage surges that can damage electronic equipment. Surge protection devices should be installed to protect fire alarm systems from lightning surges. Another consideration is the need for coordination between the fire alarm system and other building systems. The grounding system for the fire alarm system should be coordinated with the grounding systems for other building systems to avoid ground loops and other grounding problems. Another consideration is the importance of ongoing training and education for electricians and other personnel who work on fire alarm systems. Proper grounding techniques are essential for ensuring the safety and reliability of these systems. Ongoing training and education can help to ensure that personnel are up to date on the latest grounding requirements and best practices. By considering these additional factors, you can further enhance the safety and reliability of your fire alarm system. To summarize, proper grounding is essential for ensuring the safety and reliability of fire alarm systems. Fire alarm systems should have a dedicated grounding system, separate from the building's main electrical service grounding. The grounding system should be installed in accordance with the NEC and other applicable codes and standards. The grounding system should be tested and inspected regularly to ensure that it is functioning properly. By following these guidelines, you can help to protect your fire alarm system from electrical hazards and ensure that it operates reliably in the event of a fire.